All right, so your first presenter is on pain meds. Your second one is losing his voice. And I'm anxious to see what the third presenter's problem is. I'm very excited. As mentioned, my name is Scott Schall. I am an associate professor of architecture at Lawrence Technological University, where I have the chance to meet many of the people in the room and many of the people on the call today. I'm also the founding director of a nonprofit called the International Design Clinic, through which I do humanitarian design build work with communities in need around the world. In fact, Saturday, I leave for South Africa to continue a 5-year project that I've been engaged in there. And then more recently, I function as a founder of Houm. And this stemmed from a long-standing bit of research I was doing around affordable housing and the housing crisis we have within this country. And as you probably know, professors are quite good at inventing labs and centers that kind of isolate themselves on university campuses and prop themselves up with grants and make highfalutin comments, but don't really manifest in any real change in the world. And I, to be blunt, was not interested in that. I was interested in figuring out a way that we could attach ourselves to the market and begin to infuse the market with greater intelligence so as to provide truly affordable and sustainable houses. So as a result, I, with a partner, who I'll introduce in a second, established Houm, an intentional phonetic of the word itself, reminiscent of Buddhist chants and all sorts of other things. Now, you will notice there's a small powered by 3 squared. And so recently, about a couple of years ago, actually, Houm entered into a partnership with 3 squared, outfit just down there, does a lot of work with innovative construction techniques, also interested in trying to understand how to make housing more affordable, more sustainable, not afraid to use containers or anything else they can get their hands on to make that happen. And have had a lot of success doing that. In fact, the founder of 3 Squareds, Leslie Horn, sitting right there. How you doing? Nice. Thank you for being here. And so we entered into agreement to say, you know what, let's work together on this because we think that what you're doing or we're doing could actually work in a kind of symbiotic way. Brett Crandall, some of you know, is another LTU graduate, currently a licensed architect here. He is working with 3 Squared and the other founding member of Houm. You can see there my listing and accolades, and I'm sure you can stalk us online to find even more.
I'm sorry, Scott, are we supposed to be seeing your screen?
I am sharing. Are you seeing my face this whole time? What a terrible letdown that is.
I'm seeing the intro slides.
Well, I'll tell you, everyone here had an amazing presentation. Let me go back. Okay. I can show you what you were missing, maybe.
That's okay. Just wanted to double check.
All right. So there I am, my smiling face, Breck, yada, yada, yada. Remember what I just said. Okay. So one of the observations I made long ago, and everyone in this room probably recognizes, one of the reasons that our housing market is filled with bloated, unsustainable, and unaffordable houses is we're dealing with antiquated ways of building, which have manifested into kind of an industry and calcified itself into something that doesn't want to change, incredibly resistant to change. I think someone wrote up here, the hardest industry to change. I don't have the source to back that up, but I will say it's damned hard to change. And however you want to couch it, from skeptical contractors to risk-averse funders and banks to clients or tradespeople, you know, are operating on like very tight budgets, don't have the kind of largesse to be able to like suddenly like take this flyer, all sorts of constraints. And so years and years of trial and error, some me working as a faculty member, doing research, doing prototypes, some me working with Breck and our friends at 3 Squared, doing prototypes and taking on projects, paper projects. We found what we believe to be a more scalable way. I'll let you know in about 9 months when our first project is complete, whether indeed it is, or I'll be up here in tears and you can console me and that'll be fine. We're taking this risk together. But our goal is to build smarter, greener, and more affordably. So what we're looking at right now, and I'll explain the rationale for this in a second, is trying to harvest the intelligence and efficiency within industrial manufacturing, marry that with the promise of generative design, which some of we've already spoken a little bit, and then marry that with the precision manifest in digital fabrication. Now, why industrial manufacturing is the first part. So as I said a moment ago, I wasn't interested in setting up a center or a lab where I was the architect and I also happened to be the fabricator and I also happened to be the builder and I also happened to be the contractor and I also happened to be the client, right? I was much more interested in, well, just being an architect and then finding ways to have people who fabricate, and people who build, and people, and everyone does what they normally do, but to do it in a way that disrupts the kind of traditional patterns of the industry. And so we started to look at other places where there's incredible efficiency and precision at a very large scale. Where does that exist within the building industry, right? There's a lot of different answers to that question. And I'm not, and I think, not too many years down the road, the answer could be like right behind me, right? Totally. Right now, where we are in terms of price point, some examples would be pre-engineered metal buildings, right? Another example would be SIP. Another example would be mass engineered timber. I am fetishistically fascinated with those garages that you can order online for like $5,000. I'm like, they blow my mind. They're cheap as all get out, and they like make me like vomit a little bit in my mouth. But if there's a way that we can harness that incredible precision and efficiency, right, and find a way to embed some greater intelligence in that, I think we'd get somewhere. On a per square foot basis, it's really hard to beat pre-engineered metal building in terms of just cladding a space and covering that space. Now, problem obviously is that these forms of construction sometimes are very poorly detailed, sometimes are massively out of scale, oftentimes are really out of context within a residential neighborhood, and actually aren't incredibly kind to humans sometimes who want to live within them. So how do we deal with that? Well, before we get there, the other thing there is really very much aligned with a distinct context. They operate well because, well, it's a turn the crank sort of proposition. Keep doing it again and again and again and again. And you get smarter and faster and cheaper and smarter and faster and cheaper. And that's how they got to be where they are, right? So is there a way then that we can use generative design to begin to import greater intelligence to that envelope? And can we do it in such a way where we're not bloating the timeline or bloating the cost? Now, I bring that up is there's a reason that architects currently only design 2% of the houses in the United States, is we're a luxury item. And we operate based on a patronage-based practice. Like we started designing for popes, and now we design for corporations. And, we're very good at that. But when you try to take that same exact set of tactics and apply them to a very different constituency, you can get into trouble, right? And so that's the reason that 98% of the houses in this country are not touched by architects, even though we have a lot to offer that conversation. We're expensive. So is there a way that generative technology can embed a little bit of the intelligence that we bring to every project into the specific context in which we're operating without us completely remaining absent from it? Can they substitute for a portion of us so that we can infuse a little extra of us at the end and still allow for the project to meet its cost and timeline obligations? That's the question we're trying to ask and answer. And then digital fabrication. Well, I just spoke of the virtues of some of the dumbest, largest structures that we've ever been able to produce, right? But there has to be some precision and intelligence within a house. There has to be a place for the hand. There has to be a place for the body. There has to be a place that we want to live and be and sit and rest, right? There also has to be, there's within the house itself, not all walls are created equal, right? Anyone that I love to do construction work. That's actually how I entered the field of architecture, is fabricating furniture and construction work. And in my work in housing, I can tell you that all walls are not created equal. There are some walls that are very, very simple to take down and erect, and others that are quite complicated. When you run into plumbing, when you run into structure, when you run into electric, we all understand this, right? And yet within many suburban houses, many houses, the 98%, let's call it that, those walls are distributed absolutely everywhere. So every wall is equally liable to have a bit of plumbing or a bit of electrical, a bit of structure, or a bit of this. And so they're all more or less equally difficult, equally expensive. But what if we looked at, speculative office development, where the floor plate itself is largely absent much of anything aside from maybe perimeter columns, because all of the intense programmatic elements have been consolidated to the very center of the structure. That's where the vertical chases are. That's where the elevator is. That's where the stairs are. That's where restrooms are. That's where everything is. All the rest of the floor plate is left really simple. What if there's a way that we could harness the precision of digital fabrication the kind of linearity between the concept, and everything we do, we don't do anything in 2D. Everything is 3D from the start because that's where we're operating. But what if you could like seamlessly move from the 3D digitized reality into the 3D actualized reality, right? Could you embed the intelligence and allow the core of the house to have as much precision and density as what you'd find in a submarine, right? Where it's packed, freeing up the rest of the floor plate, well, to be a place of living, to be a place that people can reimagine with furniture or any other nature of things, right? It also densifies the most expensive parts of the house and frees the rest of the house to be done much more easily, much more inexpensively. I should have said some of that while showing this slide. Pretend like I did, but you could see some of our experiments here. Like, what does it mean if like stairs? So if you look back in the kind of Victorian era of housing, like stairs were this kind of flamboyant, highly ornamented moment of the house, right? And so what if we could take the precision to digital fabrication, you can see in the upper corner there, and start to realize stairs that are, cut out. And it doesn't, so it's highly crafted, but it's not highly crafted by a human hand. Well, except for the one that was manipulating the data, right? But it's still highly crafted. We learn a lot actually at home from the auto industry. We think the auto industry is quite sensible in many ways. One of the ways is if any car you look at is highly appointed in certain areas, but it's very predictable. The burled hardwood on a luxury automobile is always on the gear shift and always on the steering wheel. It's always where the hand comes in contact with the vehicle. The higher value materials are always where the eye comes in contact with the vehicle. The pressure's pulled everywhere else. Maybe we could design houses in that way. And that's what we were looking at, even within the industrial scale manufacturing you're talking about. Does the whole house have to be made of cedar to actually be homely and warm and resonate with people as a home ought to? Or maybe just the parts that actually are directly in contact with the human being as they occupy the thing? These are questions we ask and answer. Also, this kind of overt expression of what we're after, like how does the house itself in its design express the kind of values that I just shared with you? How do we allow the parts that are digitally fabricated to announce their presence within the design of the house, right? Faithfully. So let me go into like the whole objective, obviously, is to be more efficient. I've talked a little bit about that, and the efficiencies manifest in this kind of submarine style consolidation of the core elements. How can we be more effective? I know I'm running over time, so I'm going to jet through these. I'm sorry. And then again, at the end of the day, how do we be more sustainable? How do we use digital tools to understand the impact and potential impact of the work? How do we use digital tools to understand exactly where to place openings so as to harness the potential embedded in the sun, as you can see within this study? Currently, we're making projections. Again, first project be done in April. You could come yell at me if I'm wrong. These are projections from bids submitted by contractors. Currently, we're operating at under $200 a square foot as a finished build within Detroit, which those of you that work in Detroit know that that's for the quality of output that we're talking about. That's a significant savings. The $250 a square foot is for a fairly low polish, I should say, within a house. So for us to get under $200 a square foot, we're outperforming the market by a factor of 33% on a comparable quality. In terms of timeline, we are also anticipating cutting the normal 9-month down to 6-month. Again, I can do the math right now. I'll tell you, nothing has happened yet on site, so our time hasn't started yet. And mainly because everyone's so damn busy, they don't want to return our calls. We keep calling them though. We'll get there, right, Breck? The other founders right there. I'm doing great. You can just stand back there and wave. So a couple houses we'll talk about, a couple paper projects, and then a project that soon won't be paper. One of the paper projects I want to talk about is we named Martin. It's on MLK. Figure it's a nice little homage. Right there behind the dog care center, K9 to 5 on Cass. Some of you probably know that place. Lovely owners decided that the property behind that space, they thought maybe it could be a live work arrangement. So design a front building where they could use part of it as an office, rent it out, and then the back part, which could be a house, back part facing to the backyard. Again, one of the assets within industrial scale manufacturing, and specifically the metal building, is the way that the structure operates is fundamentally different than a light frame construction, right? And so all of a sudden, the way that you can articulate windows changes fairly dramatically. And so when we're talking about like, how do we create an aesthetic that is an honest expression of the assets that we have found within this different process, those large windows, as you can see, fewer larger windows is one of those expressions within the work. It also is an expression of the interior where, once again, we have the freedom of having 30-foot clear spaces like we sit in right now, maybe not quite this large. These kind of celebratory, what are called great rooms historically, we can realize that at a fraction of the cost. And so both of the large windows you see here actually are bringing light into such a great room, 30-foot tall or something obnoxiously tall. And there you see it sitting on the main street, fronting with, that's the commercial side of things. And then that's the entry side. The home itself would sit at the back. There's a elevated porchway, and then in the back there is a garage bridging the two. An interior shot. We also looked at like very, very tiny. This was done, I think, I helped my friend Chris over there, right? Back when he was a student, we were looking at like, all right, what happens if we go really tiny? And how tiny can we get? And how quick can we put this thing out? And how cheaply can it be done? And how much energy can it harness? And can it really fulfill the obligations of house? Again, paper projects, thought projects, until we got here. So this is a project, Breck, co-founder over there, also owner of this house, hopefully. You're the owner, right? Checks are still being signed. Stuff's being, all right, will be. Here in the neighborhood, 1,700 square feet, including a kind of a back auxiliary building with a bridge connecting the two. Tight lot, very tight lot. I think all told, the building itself is 15 feet wide. 18, oh my God, 15 interior, maybe I was thinking, I don't know. And just completely wrong. Again, you see this tightly wound. So if I were to show you the plan, which I probably in retrospect should have, I could have circled all the complex ingredients of the house, and it would have fit in a very, very small portion of the house, freeing the rest of the house up to be open, light filled, and executed in a much less expensive manner. You can also see this kind of wrap of wood and cedar at the moments where the human comes in contact, and then kind of releasing that and allowing the house to use industrially produced scalable materials. And at the end of the day, that's what we're interested in, is the kind of scalability of our work. Like, we from the get have never been interested in the kind of one-off proposition. And so on the first couple of projects, we are functioning as architects, as I said. But our ambition is always to build around, what is House 300? How does this feed House 300? Because when you're looking at like Ford and the F-150, right? They generate so many losers before they get to the winner. Each one of it tests a different component and fails in that test. And they don't sell those, they can't sell those. But eventually they get it right, and then they produce it at a massive scale. And that's what we're interested in doing. And I think we're logical enough to know that we as architects have not an infinite knowledge base, but there are incredibly smart people out there. And something that architects can do really well is dialogue. The best of us can dialogue and listen. And I think the people in this room do a great job of that. And that's why I'm thrilled to be here representing home with a great group back there and a great group here. So thank you. Questions? I've been instructed to hit the chat to see if there's questions.
None
I
in the
hope-
chat so far.
I was hoping that question with a question mark was not a question. That was way too meta. I don't know how to answer that. Any questions? And there's back there. What this?
So what is the panelization method? Did I miss that?
The panelization method for the digitally fabricated core.
Yeah.
Yeah. So we're using a CNC currently for that. And I mentioned Breck, I mentioned Leslie, who's the founder of 3 Squared and also a minority partner at home. I forgot to mention Ty Petrie, who is our newest minority partner in home and a critical ally in this. Ty brings a skill set as a contractor that we don't have. Ty also as a contractor recognizes the value of digital fabrication. And so he's entered in. And so there are parts of this that we're conducting in a manner where we are more or less, because home has accumulated the knowledge, like we are operating as a fabricator. But then there are larger sections where we are not. We're relying on the fabrication expertise of giant outfits that operate in places like this. So just a CNC. In a lot of respects, we're the least innovative amongst the, like we're not bleeding edge people. That's not who we are. Like some of what you're doing in here is like bleeding edge. It's amazing. And I'm so thrilled that Detroit has it. Sorry?
It's been very
Good, good. I I appreciate the fun. But you're doing like cutting edge stuff, right? We're borrowing the intelligence from others, but what we're trying to do is bring that intelligence together in a new way to create a better output. That's our goal. All right. Well, thank you all. I appreciate you listening.